All right, so I apologize. My original video got flagged for copyright because there was music playing in the background. So we're going to start at the kind of top of your toolkit here. The best that we've got, or the first part of what I see is being able to rewrite expressions. So the way that you're going to see that for a lot of your test here is going to be dealing with expanding and condensing our logarithms. So anytime you see multiple logarithms like you do here and here, I'm looking for you to condense them, meaning putting them all back down into one logarithm. Keep in mind, we said that anytime you see any adding, what that means, between logarithms, I should say, what that means is I'm actually going to end up multiplying the inner pieces. So the x squared and the y and the z are all going to end up multiplied. So if I want to rewrite this as a condensed logarithm, what it would look like is x squared times y times z. Now it's important to note that all three logarithms have to have the same base on them. Since I don't have a base here, that means the base is 10, so therefore they all have the same base. Here I'm using a separate rule, so I've got these numbers out front of my logarithms. Keep in mind we said that that means you can transfer them back to being exponents. And again, I have to check they make sure they have the same base. They do, they both have a base of 2, so the condensed version of this logarithm would be x to the 4th power times y to the 3rd power, not times, divided by y to the 3rd power, because I see subtraction in between. So adding meant we were going to multiply the pieces. Subtraction means we're going to divide the pieces. So this is my final answer. I also might ask you to go in the other direction where I give you a condensed logarithm and I want you to write it out. Now keep in mind, each piece, like each letter essentially, should end up with its own separate logarithm. And any exponents should go out front like they did up here. So this expanded would look like 2 times log base 4 of a plus 5 log base 4 of b. So they both have base 4 because this had base 4. The 2 and the 5 go out front of each of their respective logarithms, and then the a and the b are separated. Over here, similar idea, except now I've got 3 different letters, so I'm going to have 3 different logarithms. So I'm going to say 2 log base 2 of a plus log base 2 of b, and I put those in parentheses to note that they're together in the numerator, minus 3 log base 2 of c, because that's the only piece in the denominator. So rewriting would be the idea of expanding and condensing your logarithms. So that's one of our targets. Another one of our targets we're going to see is kind of in a bunch of different ways. The first way is going to be dealing with solving our expressions here. So if I start with this one here, I want to solve for x. The first thing I'm going to have to do is get x by itself, which I can't do because I've got a squared and a x, so I'm going to have to square both sides. When I do that, that gets rid of my square root. I get x squared plus 5x equals 36. From here, I want to get everything to one side, so x squared plus 5x minus 36 equals 0. Once I get to this step, my first question to myself is this something I can solve for, like, can I factor this? Or am I going to have to use one of my other methods? So this one, I believe it does factor. So if I set up the diamond, I get negative 36x squared, positive 5x. That would be 9x times negative 4x. So that tells me I can factor, like I can set up the box. So x squared, 9x, negative 4x, negative 36, so 9x, 9, negative 4. So I have 2 solutions, x minus 4, x plus 9. So that means my solutions are x is 4 and x is negative 9. I do need to go back and test those and make sure that neither of those solutions is extraneous. So I'm going to plug the 4 in. I get 16 plus 20, so that gives me the square root of 36, which is in fact 6, so that one works. If I plug in negative 9, I get 81 plus negative 45. So 81 minus 45, which would be, let's see, 41, that would be 36, which the square root of 36 is 6, so those both work. It is possible that one of those might be extraneous, but not necessarily. Now, the way that this looks different than it has in the past is you now are dealing with some situations where you have to find the solution to an exponential equation. So this is where I'm looking for you to use that Abe to Bay idea. Now, first, I need to get the exponential by itself, so I'm going to divide by 7 on both sides. You're going to notice that a lot of these problems are not going to end up with nice answers, but sometimes they do. So I get 3 to the 4x equals 14. Once I get to this point, I'm going to rewrite it as a logarithm. So log base 3 of 14 equals 4x. Now this we've talked about how to type into our calculators before. We're going to use that change of base rule. So log of 14 divided by log of 3. This is how I type it into my calculator. If you have a fancy calculator that can just do this, you can skip this step. And I get 2.402. I would recommend keeping at least 3 decimal places, maybe even 4, just to make 100% sure you're going to be accurate. And then from here I can finish solving for x. So I'm just going to divide by 4 on both sides to get my x alone, which if I do that, I get, let's see, answer divided by 4, 0.601. Again, very normal for us to get not integer answers for these. Moving on over, same thing. We're dealing with an exponential equation that I'm looking to solve for x. So I'm going to subtract the 4 from both sides. I get 5 to the x power equals 8. And I'm going to have to rewrite this as a logarithm. So I'm going to go log base 5 of 8 equals x. Again, change of base rule in order to make this work. So that would be log of 8 divided by log of 5. And I get 1.292 is my x value. Sometimes it's going to be written in kind of a funky way where I'm looking for you to actually exponentiate, so to go the other direction. So this is saying 11 to the 23rd power equals x. So I'd be looking to do that in a calculator. I get 8.9543 times 10 to the 23rd power. And if you get an answer that is giant like that, where it has scientific notation, you're totally welcome to use that. You're not going to hurt my feelings by choosing to use scientific notation. So that is really our idea for solving. Now we will see solving in kind of a different way as well. We'll see it using 3 variable systems or even 2 variable systems. So let's look at a 3 variable system first. Like we said, you're going to be able to choose whether you want to solve for x, y, or z. I always like to start by labeling my equations just to make my life easier. Looking at these, all 3 of my letters are solving for x, y, or z, pretty much a horse apiece. I'm going to start with x just because I think that makes it a little bit easier in my opinion. So I'm going to take equation A, and then I'm going to take equation B times -2, because that'll give me a positive 10 here and a negative 10 there. So negative 10x plus y minus 10z equals -2. Multiplying by -2 here, I get positive 10x, positive 14y, negative 12z equals -6. Just checking my math one more time. So 10, 14, -12, and -6, good. And then I'm going to add my 2 equations together. When I do that, my x's cancel. I get 15y minus 22z equals -8. Like I said, I always box those in just because it makes it a little easier for me to find later on. Looking at my 2 equations, I'm going to do a, and I'm going to take c times -1 this time because that'll give me a positive 10 here and a negative 10 there. Remember, we're always looking to cancel the same letter twice. So up here I canceled x. When I do this again, I have to cancel x a second time. Otherwise, this whole thing does not work the way we want it to. So multiplying this whole equation by -1, I get positive 10x, negative 4y, positive 9z equals positive 9, and then I can add my 2 equations. X's cancel again. I have negative 3y, negative z equals 7. So now I've got my 2 equations. Once we get to this point where we have 2 equations both in just 2 variables, they have to be the same 2 variables, so in this case I have y and z. Now I'm going to use those 2 equations to solve for my 2 of my letters. Looking at these, it's pretty obvious that y is going to be the easier choice to solve for. So I'm going to take my original equation, my original first equation, and then my second equation, I'm going to multiply by 5 because that'll give me negative 15y's here. So negative 15y minus 5z equals, and that times 5 would be 35. So when I add my 2 equations together, my y's cancel, I get negative 27z, and then over here I get positive 27. So that means z has to be -1. So I've got my first letter, and now everything kind of collapses in on itself, so I'm going to go back into one of my 2 equations I had here. It does not matter which one. This one looks a little easier to me, so I'm going to use that one. Negative 3y minus negative 1 equals 7. Negative 3y plus 1 equals 7. Negative 3y equals 6, because I'm subtracting that 1 from both sides. And then dividing by negative 3, I get y equals 2. So now I've got z, I've got y. I'm going to go back to one of my 3 original equations and get x. Again, it does not matter which equation you want to use. I guess to me the middle one looks the easiest, so I'm going to use that. So negative 5x minus 7 times negative 2 plus 6 times negative 1 equals 3. Just verifying I plugged those in correctly. So I plugged in negative 1 for z, negative 2 for y. Then I'm going to do my multiplying. So negative 5x plus 14 minus 6 equals 3. Combine my like terms, I get negative 5x plus 8 equals 3. Then I'm going to subtract the 8 to the other side. I get negative 5x equals negative 5. Dividing by negative 5 on both sides, I get x equals 1. So my solution, keep in mind you have to write it out as a solution, needs to be written x, y, z in that order. So this would be my solution to the system of equations. Now, systems don't just have to be linear. I can deal with nonlinear systems as well. So we'll look here first because this one's a little bit more familiar to us. A lot of times I'm going to set these up where I've got both of them set equal to y so that they're really easy to set equal to each other. So I would say x plus 3 equals the square root of negative 2x minus 7. And then I'm going to solve for x. You saw something very similar to this on your last test, I believe. So the way I'm going to undo this is to square both sides. Keep in mind you don't want to kill puppies here, so you're going to do your squaring using the box. So x plus 3 times x plus 3 gives me x squared plus 6x plus 9. You can't forget that middle term. I'm going to get everything to one side, so I'm going to add the 2x and add the 7. So I get x squared plus 8x plus 16 equals 0. Then from here, I can go through and factor this if it's factorable. Otherwise, I could try completing the square or quadratic formula, whatever makes the most sense. In this case, I'm looking for two numbers that multiply to make positive 16x squared, add to make 8x, so that's 4x and 4x, so this does factor. I get x plus 4 squared. So what that means is my x value is negative 4. Thankfully, in this case, I only have one x value, so that just means these two equations only cross in one place. So then I'm going to take that x value and plug it back into my equations. I'm going to go into the top equation because that seems easier to me. And if I do, I get y equals negative 1. So my solution is negative 4, negative 1. Again, you have to write your solutions as a coordinate point. Now this looks really scary at first because you're like, oh my gosh, there's exponentials in a system of equations. I have absolutely no idea what to do. But again, it's set up the same way. So I see they're set equal to y. So I'm going to set them equal to each other. And then I notice they both have the same base. This is a very convenient thing here. If they happen to have the same base, or you're able to get them to a point where they have the same base, what this is telling me is that these two exponents have to be the same. So if the bases are the same, which they are, they're both 2's, I can actually just kind of ignore them and focus on these exponents. Because in order for this to work, it has to be true that 3x equals x plus 8. Now I can just solve for x. So subtract one of my x's from both sides. I get 2x equals 8, so x has to be 4. Well, that's convenient because now I can take that, plug it back up in here, and get out a y value. So I'm going to take 2 to the 12th power, which I do not know off the top of my head, so I'm going to need a calculator. 2 to the 12th power is 4,096. So again, it has to be written as a coordinate point. That means that these two cross at 4,096. Next part of our test is going to be on inverses. Again, these are coming back, so you need to be able to come up with an inverse equation for a variety of different equations. You will notice that exponentials and logarithms are going to come into this. That's a pretty popular choice on your test moving forward. So we'll do what I would consider the easy one first, where this is where we're going to get our inverse first. Keep in mind our first step is always to flip x and y. So this becomes x equals, because keep in mind f of x is the same thing as y. x equals negative 4, y plus 5 cubed plus 1. I'm going to subtract the 1 from both sides. Divide by 4. Again, do not try and simplify all these things, just leave it the way it is, because I actually like being able to see like all of your steps, how you undid adding 1 by subtracting 1, how you undid multiplying by negative 4 by dividing by negative 4. Then I'm going to take the cube root. So I get, again, don't simplify, the cube root of x minus 1 over negative 4 equals y plus 5. And then I subtract that 5 to the other side. And because I like to have the y equals on the left side, I'm just kind of flipping my whole equation over. And I don't want that to be inside the square root, so I've made like a little garage door to show that my square root, or my cube root, is ending here, and then minus 5 is outside of that cube root. Now, logs and exponentials, again, seem a little bit scary at first, but we're going to start the same way. So first things first, we're going to flip our x and y. So this is going to become x equals 3 to the y power minus 1. Now, anytime you have a log or an exponential, you want to get that thing by itself and get everything else to the other side first. So I'm going to move the 1. X plus 1 equals 3 to the y power. Once you've done that, now we're going to flip it to the other version of what it is. So a reminder, we said Abe and Bay. So right now this is set up in Abe format. I want to flip it to Bay format. So log, my base in this case is the 3. My answer is the x plus 1. And then my exponent is the y. So this is actually written, that is the inverse of my original equation. Coming up here, it's kind of the other direction, but the same idea. So I'm going to flip my x and y. So I get x equals 7 log base 2 of y minus 3 plus 1. Same idea, you want to get the log piece by itself, just like we wanted to get the exponential piece by itself down here. So I'm going to have to get rid of this plus 1 and this times 7 first before I do anything else. Order of operations when I'm solving is always undoing things in backwards order, so I have to subtract the 1 first and then divide by 7. Again, I cannot stress this enough. Don't simplify, because trying to simplify this, you're going to end up making a mistake. That's usually where it happens. Now that I'm here, I see I'm in Bay format, written kind of backwards, like my E is in front this time instead of behind, but it's the same idea. I want to take this and turn it back into Abe format. So I'm going to start with my base because that's the easiest one to identify. My base is 2. And then since I wrote it backwards, my exponent is what's over here. So x minus 1 over 7. And then my answer is y minus 3. And I'm almost done getting the y by itself because that's always our goal. We want to get the y alone, Here, I just have to add the 3 to the other side. So I end up getting y equals 2 to the x minus 1 over 7 plus 3. So those are my inverses. Last piece of our test is graphing and understanding key features and stuff. So let's start with parent graphs. So I might give you a different type of parent graph. Since we've been talking the most about logarithms this chapter, you could bet that the graph I'm going to ask you to do is either a logarithm or an exponential. So I more than likely am going to give you the parent graph. So you'll have the parent graph at least to start, and then you're going to have to be able to tell me what sort of transformations are going on here. Keep in mind that A always comes from whatever's in front of the logarithm. H is going to come from in here, and keep in mind that one is opposite of what you see. And then K always comes from the very end after all of the logarithm pieces. So looking at this particular equation that I made up, I see an A value of 1 because there's nothing there. My H value is going to be negative 4 because, remember, it's always opposite what I see, and I see a plus 4. And then K is negative 1. So what that tells me is that this graph has been moved left 4 and down 1. So you could go through and plug in a bunch of points and get out answers, or you can use kind of a little cheater method here, where if you take your parent graph, I'm going to take each of the coordinates I can see, and I'm going to move them to the left 4 and down 1, because that's exactly the transformations I'm going to have. So that would put this coordinate, instead of being at 1, 0, is now going to be at negative 3, negative 1, because I moved it backwards 4 and down 1. this coordinate, which was originally at 10, 1, is going to go backwards 4 and down 1, which will put it at 6, 0. So my new graph is going to look more like this instead. I will ask you to be able to identify the asymptote. Keep in mind we said the asymptote is always going to be at x equals your h value. So whatever that was, in this case it was -4, so my asymptote is at x equals -4. And all that means is that my graph is never going to cross over the line x equals -4. That helps me write my domain, which by the way is going to be another target on your test, because my domain is always going to go from that asymptote and then either up or down. In this case, it goes up, so -4 to infinity. Keep in mind parentheses are used for infinities and asymptotes. Brackets are used for points. My range, although it doesn't look like it, it's going to go down to -infinity because my graph is going down forever. And even though it's going up really slowly, it's going to go up forever too. So it goes up to positive infinity. So this is kind of two targets in one. You're going to have to be able to graph, talk about AH and K and any important features, as well as domain and range. I might also give you an equation, something like this, and say, transform it, move it left 3 and down 1. So you have to look at the equation, know where A, H, and K go, and then make the appropriate transformation. So in this case, since I want it to move to the left 3 and down 1, what I'm going to see is x plus 3 minus 1. Might also do the same thing with a exponential equation, like y equals 2 to the x power, and I might tell you to stretch by 5, right 1. So then you would have to recognize stretch is an a value, meaning I need to put something here, and right 1 is an h value, it's got to go up here. So my equation ends up being 5 times 2 to the x minus 1 power. So that's what you can expect.